Okay, for number 10, it's asking you to determine whether the function f of x equals x squared is even, odd, or neither one. In class, we focused in on the graphic, the visual approach. We're going to get into the algebraic approach later on. So if you graph y equals, or f of x equals x squared, it looks like the graph below, and it's symmetric with respect to the y-axis. If you fold along the y-axis, which, this is your x-axis and this is your y-axis, if you fold along the y-axis, the two sides should match up. Okay? Now, my picture probably doesn't because I just drew it freehand, but if you use a graph paper and everything, it'll work out. So this function right here is even because it's symmetric with respect to the y-axis. Okay, so for number 12, they ask you to describe the transformations that are happening here from f of x to g of x, and then to graph g of x. Okay, so first off, identify the parameters. So this one right here is b, this is h, this is k, and right here in front of f, is your a. Well, a in this case is 1 because there's nothing in front of f. B is -4, but remember it's counterintuitive, so we're actually going to multiply by 1/4. H is 3, and k is 1. So when you describe, you're going to say that g of x reflects over the y-axis. You have horizontal compression. Remember, it's not stretch even though it's a 4 because B is counterintuitive. So, compression with factor of 1/4. And then it translates 3 units right, because again it's H is counterintuitive. If it says -3, it's actually to the right, and 1 unit up. So this is all you have to write for describing the transformation. Okay, so now we're going to graph it. Alright, to graph the function g of x, I start off with f of x. The points that I use for f of x are -1. If x is -1 and you square it, you get 1. If x is 0 and you square it, you get 0. And if x is 1, you square 1 and you get 1. So the 3 points that you see on the green table, those are the points for f of x. Now g of x is a transformation. So what's going to happen is the x from f of x is going to be multiplied. So -1 is going to be multiplied by -1/4. And then we're going to add 3. Because remember, b and h affect the x. Okay? And then the y is affected by a and k. Well, a is 1, so it's not going to show any change. So we're going to take the 1 and we're going to add k, which is 1. Oops. I'm going to write k instead of the number. So 1. Okay? So here, for the first point, I get -1 times -1/4 is 1/4 plus 3, so that's 3 1/4. For the y, 1 plus 1 is 2. Okay? Then we move on to 0, 0. Well, 0 times -1/4 plus 3. So that's 0 plus 3 is 3. Over here, 0 plus 1, we're adding k, that's all we're doing, is 1. And then the third point, 1 times -1/4 plus 3. So this is actually 3 minus 1/4, right? Because 1 times -1/4 is -1/4. So 3 minus 1/4 is 2 3/4. And then on this side, the y is 1. Okay, so here's the ordered pairs. 3 and 1/4 with 2. So 3 and 1/4 with 2, 3 with 1, and 2 and 3/4 with 2, and that's what we're going to graph. Okay, so here you have, I set up the graph, the XY coordinates plane, and I graphed with a dashed green curve. I graphed the original function f of x. So this is just f of x equals x squared. Now in blue, I'm going to be plotting the points that for the g of x function that we created. So 3 and 1/4, 2, 3 and 1/4, 2. So 3 and 1/4 would be about here, and 2 is right here. Let's see if it's showing. That's good. So 3 1/4, 2 about here. And then 3 1. It's about here. And then 2 3/4, 2. So that's about here. So look how skinny that parabola is, because it got compressed horizontally. So it got squeezed in horizontally. So it's going to be kind of like this, like that. So as you can see, it did translate 3 units to the right and 1 unit up. Okay, and then compared to the original, which is x squared, this is what the 4 does. Okay, and then because it was reflected over the y-axis, that's why it's over here on this side. Okay. Okay, so for number 5, f of x equals negative 2x plus 3, we're going to find its inverse, use composition to prove that the inverse is correct, and then we're going to graph both of them on the same x and y plane. Okay, so first thing, replace f of x with y, and then we're going to solve for x, so that means subtract 3. And so you have y minus 3 equals negative 2x, divide by negative 2. So x equals y minus 3 over negative 2. Now, it's common practice to have the denominator positive. So we're going to move the negative to the numerator. That means distribute the negative on the top with the y and the minus 3. So we end up with minus y plus 3 over positive 2. So now we switch the x and the y. So y equals negative x plus 3 over 2. And then we change to the y into f inverse of x. So this is what we got for the answer for inverse. Whoops. So we have to prove it now by using composition. Okay, keep messing up on this one. By using composition. So we're going to do both directions. So here's the inverse. We're going to do f of f inverse of x and show that it's equal to x, and then we're going to do the other direction. So what this means, remember, is I'm going to take this function f of x, and wherever I see an x, right here, I'm going to replace that with the inverse. And then I'm going to simplify and see what I get. So this equals negative 2 times negative x plus 3 over 2 plus 3. So I'm going to multiply the negative 2 by the parentheses, so the 2 over 2 becomes 1. 2 over 2 is 1. Negative 1 times negative x is x, and negative 1 times 3 is negative 3, and then don't forget we have a plus 3 on the outside, so the 3 minus 3 cancels, and you're left with x. So that side works. So now I have to show the other direction. So f inverse of f of x. So we're using composition. Okay, so now I'm going to take this function right here, f inverse of x, And wherever I see an x, which is right here, I'm going to replace that with f of x. Okay, so negative 2x plus 3 plus 3 over 2. So that's what this equals. So distribute the negative, I get negative times negative is positive, so 2x minus 3 plus 3 over 2. So 3 minus 3 cancels, it's 0, and then you end up with 2x over 2. The 2 over 2 reduces to 1, so we're left with x. So what this proves is that our inverse is correct. And so now the last step, the last thing we're going to do is graph it. Okay, so I've got it set up here so that you have the line y equals x already on the graph, on the xy plane. Remember, our two functions, f and f inverse, have to reflect over this line y equals x. So let's start off by plotting f of x, which is negative 2x plus 3. So we know that I'm going to start on 0, 3, and the slope is 2, so that means I'm going to go down 2, slope is negative 2. I'm going to go down 2, right 1, and do that another time. Or I can go up 2, left 1 from my first point. Okay, so right there's my graph, my points, 4 points. And as straight as you can. I know with a stylus I can't really use a ruler, because then it's trickier. So blue line is f of x, so label it. So this is f of x. To graph f inverse of x, I can just take the points that I have on the blue line and switch them. So instead of 0, 3, look up here, I'm going to graph 3, 0. 1, 1 is 1, 1. 2, negative 1 is negative 1, 2. And negative 1, 5 is 5, negative 1. Right here. You can connect these points. This one came out a little bit nicer, or straighter at least. And this is f inverse of x. And it matches the equation. Remember, the equation for f inverse of x was negative 1/2 x plus 3 halves. So here you have 3 halves is 1.5. That's the y-intercept. And then we have the slope down 1, right 2, negative 1/2. So it matches. Okay, for number 6, they want you to find the inverse